Hello everyone, I'm Andrew from Teams Quebec. Have you ever been to a party where you've met loads of people and you've spoken to loads of people and you want to add them on social networks the day after? We've not been able to remember the names. Wouldn't it be great if there's a way to take a quick video of a room, a quick scan of a room, and then use facial recognition techniques in order to detect who was in the video and present at the party? Well, that's what our project, Quebec, aims to solve. It's a social media platform through an Android application which allows people to upload videos and then facial recognition algorithms work over videos in order to detect who are present at the events. So how does it work? Once you've downloaded the app, you create an account either through Facebook or with email and password. And then you upload a training video which trains the system to recognize your face in other people's events. You can then follow friends to see the events they've uploaded or events they've been tagged in, and also you can upload your own event to identify people who you may want to follow. So I'll go through some screenshots. So this is the login where you can log in with Facebook and email and create a new account. This is the events feed, what shows events that you may be interested in, such as events that have been uploaded by friends or events what you may have been tagged in. The profile page which shows a number of followers and people you're following. You can also follow new users from this page and update profile picture and your training video. And then from the bottom bar you can upload a video which will then get processed in the background, and then you can add a name and it automatically detects the location which is then tagged with the event. Once you've saved this, you'll get a notification when the processing has been completed. This goes to the events detail page, which is effectively the heart of the application. It's got the details of who was present at the event. You can upload new videos to an event, so as more people upload videos, more users can get tagged until you can get a full guest list collected from people present at the event. And it also shows like map for the location. So this is a summary of the front end. Now I'll pass on to Pete to talk more about the facial recognition.
Thank you. So our app is essentially split into 4 distinct layers. I was working on sort of the most back end, if you like. So I was building a system which performs our face detection and recognition, but really has no knowledge of the rest of the app. So it's very well isolated from that perspective. So for the detection recognition itself, we were using OpenCV. That provides us with the hard classifiers and local binary pattern histograms for each of the detection recognition. On the side of that, just to achieve those tasks, we needed to store the data from a recognizer. So you run a recognizer once on an image and it produces a histogram which you save. For now, they're stored locally in our EC2 instance, but there's no real problem in putting that onto S3 instead. We're using a lot of other Amazon technologies, so that's pretty simple to do. The other thing we had to do was interact with our other back-end. The API is running in Amazon Lambda. For that, we're using Amazon Simple Queue System, which is a message passing interface for us. Which kind of heads it towards more of a distributed system for us. And all of our data is stored in S3 to be passed to us. So I've just got 2 sort of flowcharts for each of the training and detection algorithms. So for training, we're using a Laplacian filter, so we're trying to pick the least blurry images. Essentially, split the video into frames and then pick the least blurry ones if you can. Having selected those, we're then trying to take at most 10 of those frames in a uniform distribution across the video. So if you were turning your head while you were taking the training video, then we want to try and get as much of that data as we can. Essentially, if you train on 2 frames that were adjacent, then you don't get much more information out of doing that. So we try to split it uniformly. When we're recognizing somebody who's been to an event, essentially we just have to run that through the face detection to find all faces and all frames. OpenCV then tends to produce a lot of very small faces that it thinks are there, which really aren't faces at all, they're just extra detections. So we ran that through a size filter to get rid of those, and then asked it to match the user that it thought that face was. And then the final sort of heuristic we were using was essentially that it's impossible for a user to have entered a video in one frame and left it by the next. That's just not possible in sort of conventional time. So we filtered that out so that a user had to be in at least 10 frames to count as a full detection. Finally, a little bit on scalability. Scalability seems to be pretty good. So OpenCV is written in OpenCL, so it will naturally scale onto any CPUs and GPUs we give it. And the backend's been written with this message passing scheme, so we can just spin up more EC2 instances, and each job is segregated from all the others. So that should work quite well. Thank you.